we'll go back to the beginning here. So, Binny Building's over here, in the front end screen like we always have. Go ahead and click on Binny Building. Just like everything else, we had put um, hyperlinks buttons right to some of the major screens that we always do for everything. You know, air handler screens if you want to go straight to them, stairwell pressurizations, HMVs, the air handler unit summary screen, so you can get a quick reference screen that guys know what the summary screens are. Chilled water systems, low temp chilled water. We'll click on each one of these in a minute. Heat exchanger 1, 2, 3, 4, shield coolers, domestic watt, and construction exhaust. Those are quick hyperlinks to some major mechanical systems. And as
You're not
always,
gonna have one for regular exhaust?
Like general?
Any exhaust fan that you click on,
we'll bring you to an exhaust matrix screen to tell you all about it. You know what I'm talking? So we'll show you that in a minute. Like usual, click down all the floors in the building.
Mm-hmm.
Our standards moving forward, as we always talk about, is that every floor plate has to show every piece of equipment that we're responsible for on the floor plan. You know, even if we're not, even if we don't have connected points for any kind of alarming and all that stuff, we still want to have a picture of it to show us the location of the equipment on the graphic.
Mm-hmm.
So we'll start at the bottom and work our way up. So here is the Binny building basement. Just to let you know, Robert Toma has been working for the past couple weeks, reviewing every one of these graphics, making sure all the equipment in the areas are going to be on those graphics. So some of the stuff is not on here right now. We just want to give you the premise of what is on here and what things will be on here moving forward. They'll have the program space. If there's a name on the door like fire pump room, mechanical space, electrical vault, all that information will be saying that on those screens. Just not room numbers, but we'll have little descriptions of those rooms, what they're allocated, what the program space is. So on here, as you can see in the basement area, we have the fuel tank room area. So on the fuel tank room area, we have multiple facet things you can click on. One is that we want to check out the fuel tanks themselves. So each fuel tank has a oil level indicator in them. So these are the gallons, how much in tank B, and the gallons in tank A. So if we click on either tank, are they not?
No, so since our last conversation, you had wanted to zoom in on the system.
Okay.
So I really want to sit with you and figure out that system, how we want it. So the information that we have available that's new from Binny is on the right there. The command and the pressure alarm.
Okay. So what is this?
Well, those are the tank levels.
Yeah, that's what I said, the tank levels. Yep. And so we click on this.
The information is off of there now, so that's just the main and enders fuel oil system.
Okay.
But we'll end up with a zoom in very similar to that with
Okay.
your day tanks, the information on
You
that.
have a flow diagram as well. So
Right.
Do a whole package on that.
So, in essence, this is really not going to be the stuff that pops up, but this will be removed because this is really pertaining to main and enders. We'll actually have a new pop-up window showing this fuel tank system over to the day tanks in the generator room, which goes across here into this area here, which is the main building generator room. You know what I mean? Main building generator room area. Some of the things that we did is to enhance this, and Jamie's working on now, is if we wanted, because this building is an extension of main building, so we want to be able to look at this floor plate and go, hey, we need to go right over to main building and look at that because it might cross over. So there's a hyperlink button here. It's not done yet because he has to
Get you back.
spell it out and get you back.
Mm-hmm.
Because once you go over to the main, we don't have a hyperlink to come back. The Binny portion's not in the main building. You follow me?
Right.
So if you did, like, we could click on it. It does work and takes you now over to the sub basement. So you were just here, you know.
Yeah.
So it just
you
popped
have
you
to
through.
Go back to the main screen to get back in right now.
You got to go back to the main street to get back. But that's not going to be the case moving forward. So obviously the fuel pump room over Binny is up here, and this is the generator room and the generator rooms with the day tanks and all that stuff. So when we click on that fuel graphic, we'll have a blown up exploded view that shows Binny and main in one view, showing the day tanks and the fuel configuration and all that kind of stuff. All right? So to get back, unfortunately, until we get the hyperlink buttons to get back to Binny, you just have to go through here and back to Benny, back to where we were. All right, so that has to do with fuel. Elevators, as always, they're shaded out showing the elevators where they are. Any of these blue dots, you look over here, water sensor. All of our floor water sensors are shown on the graphic locations approximately where they are in these areas on every graphic floor plate when we go up. So you know where they are. They're not interacting, they just show locations of where floor sensors are. So we do have a work order, Jimmy, at least the guys will understand it. You know, from that work order, if they have a question about, hey, where's this floor sensor in? They can go to the graphic and pick it out. Because we go test these. We test these things, we make sure they ring into Operations Center. Moving down, each location that has a temperature sensing in them for rooms and all that stuff will have its typical T-stat. Obviously, this is the legend over here. It's an IA VAV box. We'll know what they are as we go through. You click on them, it brings you where you need to go. Each floor has what they consider a UPS system on it for the controls. For every network switch going up, there's a UPS system on that floor. If you go to here, this is not developed yet, but every one of these will have a hyperlink to a UPS floor plate. We'll tell you where they are. Basically, it's the same floor plate as the AHU serving. This here will also have the same kind of graphic, but it'll say UPSs on it. You'll be able to click on that UPS, and I'll show you what's going to happen. Right now, it's on this floor plate. It's going to get moved over. You get to this screen. It'll highlight the one that you just clicked on. This is UPS in the sub-basement. It'll tell you the temperature of the UPS running. It'll tell you the input voltage that the UPS is seeing. It'll tell you how much time is remaining before the power to the network switching and all that stuff goes down. And if it goes into alarming, it'll tell you how many times it's doing the alarm counts. If you want to know more details about this and anything about that from there, there's a web interface. You click on this and it brings you right to a web interface from Emerson.
And
Yeah, every time you click on it, if it says that, just click add, close, and
This
it brings
is
you
the
in.
first time you
It's
bring
just
that
the
up.
first time in case we didn't do it. This brings you into a separate, an in-depth screen to show you what's going on with that Liebert unit, the input voltage, frequencies, what's it at, the battery voltage, charge, if it's at 100% charge, time remaining, it's got 43 minutes remaining. The way this will work is it calculates how much power is being used out of the UPS, and it knows how long the batteries will last. So if you pull the plug on this thing, it's saying that you can get 43 minutes before that thing just kaputs.
Rashes.
Okay? Very useful information and stuff. For when we're troubleshooting, we have power outages and all that stuff, you'll know. Okay? Anybody have any questions? This is a little bit more in depth. I don't think we'll be doing too much of this, but it's great for higher end, for the IT people and all that stuff, to do maintenances and check UPSing and all that stuff.
the reason I had put this on the graphic is there is a numbers of alarms
Mhm.
on that front page, and when you click on this, that on the bottom it says no alarms present.
Right here.
If there were alarms on the very bottom there,
Mhm.
active alarms on the right side. So it says no alarms present. If there are alarms, the description of alarm, the type of alarm will be there.
Okay? So you know if you have UPS problems, you know where to look and all that kind of stuff.
That's
Okay.
helpful, yeah.
When the UPS goes down,
Yeah.
what other alarms are gonna generate? You're gonna get everything on that.
If you close this,
Everything that's,
so when it's on UPS power, there'll be an alarm. I mean, if it's in red underneath. So there'll be a running alarm, so it'll let you know that it's on UPS power
Mhm.
right when that happens.
Okay?
So now you got to take action because it's on UPS.
You can
for
look
some
at it and
reason.
you could say, hey, I got 43 minutes left. After 43 minutes, I know I'm not going to have
Like,
any
I
power
know-
to my controls.
over in the CLS building, we've had UPSs drop out,
Mhm.
and we've had to go over and plug into normal power.
Exactly.
So this is gonna tell us we need to go over there, get into another outlet that serves it to keep our systems up.
That's right. That's right.
Are they gonna change those over there too, to that?
Eventually. We're doing cop building right now. We're
Okay.
working on it.
Right,
Okay?
that's a big help.
Is it?
Trust me.
Mhm.
But that's why we've gone this route.
We've got stung a couple times on
Yeah.
this.
Yep.
One was up in the data center, and then another one with
That's right.
the like I said to the guys, like the chill water plant over CLS went down twice, and usually that animal room comes up first, and we get over it's usually at UPS.
So I think this is going to be helpful.
Yeah.
That's why we did it. So spent a lot of time, efforts, and monies to perfect this. So, and we knew it was a necessity. Okay, so that's the UPS. Like it says, this is not all the same thing. There will be a hyperlink building to your UPS stuff here. It won't be on this floor plate moving forward.
Cool.
You can see it on an upper floor. JB just hasn't got a chance to do it. This here is a condensate tank. Just tells you conductivity if a pump's actually running, not running, if there's stuff going on, if it's in alarm. Tank temperature 133 degrees. It's condensate tank. Those are the same stainless steel tank systems that we have, all the new ones that we're putting in. That's just a lawn connection to that tank, getting information, letting us know and alarming. All right. Exhaust fans. You talked about the exhaust fan thing. So we click on that. It brings up Binney Street exhaust fans in the basement level. It brings in the 4th floor fans. Okay. And it just tells you information about all that stuff. We want to make sure that every one of these you have a hyperlink to. You can tell what's going on with it, whether or not it's an alarm, and where it's where it's serving. Okay.
Mm-hmm.
One other thing I don't see down here, Jamie, I want to make sure is I want room numbers. I don't just want sub-basement gas cylinder room. It should be a BB blah blah number, whatever it is. All these room numbers, so they understand that exhaust fan 7, it's serving this room. You know, there could be multiple room numbers actually. It all depends. Alrighty. So, I think I've talked about everything. There's another condensate tank down here. That's the one in the steam tunnel.
When you click on that exhaust, does that show you every exhaust fan in the building, or just?
So it's sub-base, this one is sub-basement 4,
There's
and then,
another
Then
one.
there's another one.
and then there's one for the penthouse.
Yeah. Penthouse and roof, I'm assuming. Okay. We saw some of this stuff here. It's going to change a little bit, but that's the command and on and off for the fuel oil system pressure. We're waiting to, like I said, finite this graphic up here. Alrighty? Anything over here, we have AH2 serving floor. You click on that. It's telling you that BB1, right here, does this whole floor plate. Very easy. BB1 serves down here any fresh air ventilation.
And you can click on the color indicator in the top left,
Right.
and that'll take you there.
That'll take you to BB1. Okay?
And the overrides.
Mm-hmm. We'll go through air handlers in a minute. Okay, so if we're all set there, unless there are any questions on that, or you see something that you don't see or missing and you think it'd be better,
What do we got flashing up there, Steve, by the tanks?
because the fuel oil system's offline,
Okay.
that's the fuel oil pump system. It's offline right now because we're feeding off the other system. Until we put that online officially and divorce off the other ones,
It's gonna
that'll
stay
all
on.
clean up.
Okay.
Alrighty.
There's a fan coil unit down there, 00211, right? It's supposed to go in there, over near the Enders connection. Down the
Right
bottom
here?
there. Isn't there one in that
Yeah,
area?
there's a T-stat right there.
Right there.
It's a big unit.
Fan coil.
Yeah, it's cool.
We have the valves overridden open on the sub-basement stuff for the balance, so it finishes balancing, so if you
Okay.
see stuff overridden.
Right.
Alrighty. Okay, so I'm gonna go up the building now. Now we're on the first floor. On the first floor, as we talked about before, now is there any flow measuring station in the basement?
Just-
In the
Eptrons.
sub-basement, there's 2 exhaust fans.
Any flow stations with them to tell us the flows?
Only for the 2 exhaust fans.
Alright, so we need that. James, we're missing that because I didn't see it.
We're on the exhaust fan screen.
You want the total exhausting from
Yes,
floor.
Okay.
yes. I need the same. No. Meaning, like this here, I need a screen like that for the sub basement. If you don't have one, meaning there's nothing down in the middle, then we don't need that screen.
I don't think there's a,
Oh, there is. Oh,
is there a
okay.
supply air
He says
flow
so.
Yeah.
I
station?
believe there's a
Yeah.
balance support that makes it-
So I need the screen for the sub basement.
So you-
Yep.
So, going back to the first floor. Now, regular first floor plate, same systematic things that we've done over and over and over. Okay. One of the things that's a little different here. What are these here?
Isolams.
Isolation rooms. So down the extension of the emergency department is the first floor, as we go up. And we have all thermostats here going around. Like I said before, we'll tell you what the existing exam rooms and all that kind of stuff, what the building says. These are our isolation rooms. I'm not gonna show you the graphics yet because I'm not 100% sure if we're ready for that.
Those ones are pretty good. I mean,
Remember I sent you the standard one from CB11? That's how I want to, that's how I want it.
there's no ante room to this guy, so
Okay.
he
So we lop off the ante, but everything else stays the same. And we have the pressure relationships and all that stuff in them, right? So, we'll give it a look. Like I said before, it's got to say isolation. You got to title these. Isolation room O222, space temps, all that stuff. Pressure 0. They must have the door open. Don't we have door contact closures on this?
Disables the alarm if the door is open.
Can we do? Does this tell me anything? Can I get that on the screen to tell me that the door's open?
sure.
Yeah, why don't we do that? If it's in a disabled mood, that means the door's open. We should have a door open. If it closes, door closed. So if
Okay.
you look at it's open, you're not gonna see pressure. If it says closed, we should see something there. We should see a relationship there.
Alarm or just a point?
Just a point. I don't need an alarm. I don't want an alarm.
Status of the door.
Just the status of the door. So that way there I know by looking at this. That tells me this door's open if I'm reading this. That door's closed, this should be reading something.
Hopefully.
Better if it's not, I gotta talk to balances, I gotta talk to somebody.
Exactly.
That has to work. You know? That has to work. Because if that's at 0 and I get a door contact shows I'm closed, something's wrong with my set points or something's wrong. You know, it should be ringing an alarm after so much time. You know what I mean?
Mm-hmm.
And then air changes 11 calculated, humidity 46%. Excellent.
The alarm settings that we have on the air changes, we've picked arbitrarily based on what values we actually have for air changes. We really need to identify what each room needs to be for air changes and alarm conditions, you know? So
The-
we can
right.
work with you on that, but the set point's adjustable, we just
Yep.
pick numbers at the moment, yeah.
We can go up there, you know, talk about Jimmy? We can go up there and change this once we get confirmation, because what's gonna happen is, where we're gonna get that information from is that spreadsheet E&E's doing on all the air ventilation requirements for the building. Air changes, that, and all that stuff, what is meeting code, the whole bit. And then we'll take that, we'll cross-reference those particular rooms that have all these controls on it. And then we'll make the adjustments and set points from there. That might be confusing to most of, but does that make sense?
Yeah.
Alright. So differential set point, it's a negative 275. So exhaust flow is 500. Exhaust flow set point's 496. That's good. That looks good. Max flow is 225. Actual flow is 210. Mid flow is 225. Flow set point's 225. So max is 225.
This particular
Axle plus
setup is a
218.
constant
I was
volume
gonna say
room,
this is
yeah.
this means it's constant volume.
Yeah, doesn't have to be, I mean, you could make it different if you wanted to in the future, but right now it's set up as a
So
constant
contract
volume.
drawings told you to make this constant volume. So what tells me is that this shouldn't move much from any of these readings, because if my exhaust is tracking supply,
Yes.
so if my supply is set for 225, it's going to maintain 225 all the time. I'm going to have an offset of 275 in there for exhaust, so I'm going to add 275 to 225, and I should be at this number here. It should be trying to maintain that number. That's going to give me sufficient air changes, and it's going to give me my pressure relationship between the corridor and the door. Yeah, and I'm actually, Jamie, I like the directional arrows.
Mm-hmm.
The directional arrows with the red. Okay, with the green for positive, red for negative.
Yep.
Okay. And that'll tell me my flows are good and all that kind of stuff. So my fan command is on. The status is on. Reheat 50% open. Reheat radiant panel is open. And we got that going. Space temp is set point. Okay. Anybody see anything in here that doesn't give you enough information to understand what's going on in that ISO room? I think that's pretty good. Small tweaks, but I think it's good.
Yeah, I think the low space temp should be brought up. Set point.
Where are you?
10
This
degrees
here?
Fahrenheit
10
isn't,
degrees
isn't high enough
Fahrenheit,
for you?
this is gonna be,
Oh, alarming, you mean?
yeah.
Oh, yeah. Oh. 10 degrees. So, I mean, like I said before, those are adjustable. Once we figure out the things, we can go in there, we'll make all the adjustments necessary. They gave it to us, control of it. So, okay. We can go in and double click it and
I think
make it
just
40.
trying to avoid a bunch of nuisance. And
Yeah.
Okay.
Guys will walk in and shut the hand
Yeah,
valves
yeah.
off and the room will drop to 65,
Yeah.
60
Yeah.
degrees. And
You'd
Yeah.
have a million nuisance alarms to get the whole building straight.
Exactly. Once we get close to turnover, we can adjust our alarming properly, you know. Okay. So with that one there, I gave Jamie some direction. He has a bunch of things he want to do there.
Don't hit that.
So, why
That's
do
the
they call
summary
the
screen.
Benny built? They call the EW the basement level, and they call Benny 1.
I'm sorry.
On the main building, why do they call?
Basement,
Yeah, the
because there's a first floor mezzanine.
I know.
I know it's
really.
it is confusing. So main first is really not main first.
It's it's the
Main
ground
basement.
floor. Yeah.
That's what they call it, the basement.
Yeah.
MAB.
Alright.
Unfortunately, we got to stick with the naming, even if it doesn't make sense to us. We have to stick with it because it'll be confusing if we don't. You know what I mean?
Alright.
You'll say, wait a minute, I'm on first floor, I got to go to main basement. Well, yeah, because that's really what the main basement's called at that time. You know, because the first floor of main is really up near the bus stop area, which is not a floor at all. It's just this very
Right.
small section. All right.
Because the old winter garden.
To the old, yeah, it's exactly. All right. So, from here, area served, we talked about. That's just an area served, but it also shows it's the same graphic thing, but we just want to make sure everybody has an understanding that there is a hyperlink if you just want to look at area served. UPS and flow measuring stations, guys. This is a little different for you. Excellent, excellent screens to go by. So this shows you here every single takeoff for supply, exhaust, return, you name it, on every floor, has an Ebtron flow probe in it. You know how much CFM is coming from AHU1, right? AHU BB1 supply. Out of this ductwork supplying this area, this floor, is 5,397 CFM. We're returning 3,620 CFM into the return right over here, duct, and we're exhausting, right, 3 locations of ductwork that branches out on the floor now. This is just the shafts that we know are going to this floor. 735, 5 something, something, so
Those are the things.
right. Those are the fans, okay? Then we have totals here. For a total supply to the floor is this. Total exhaust from the floor is this. It's telling me that floor is negative, which I have to go back to the balances and all that stuff to figure that out. Because no floor's got to be negative.
Well, so
They all have to be neutral or positive floors. Go ahead.
Are you just questioning on that reading? The balance is going through and balancing all, confirming all of the flow stations, so some of these numbers might need to be adjusted as far as what he's reading after each reverse is the duct.
Okay.
So, so some of the numbers that you see, I mean, some of the readings might be a little bit strange, but, primarily we're going through the balance there
Right.
and the balance.
Just so, from my standpoint, when I'm all said and done and this project's being turned over, that is not acceptable to readings. There's something wrong there.
And
So if those are accurate readings, there's something wrong with the balancing, there's something wrong with the systems. That's all I'm pointing out, Frank.
No, I understand, sure. Because I know you're looking at it, and if you
Yeah.
sit there and you're like, that shouldn't be negative, the balance is going through, and we have
Exactly.
he's traversing all the ducts and we're calibrating the.
So when we're done, you should see a total supply greater than the total exhaust on the floor,
What's
on
that?
every floor.
what's the red square in 0223?
That's getting removed.
That's getting removed, yeah.
Okay.
That's not supposed to be there. Okay? So, those are all screens that are going to be extremely helpful to us for troubleshooting, watching things, and all that kind of stuff. So, alrighty? Moving up. Anybody else want to do anything on this floor here? I'm sorry, I didn't. So, you see the Blues T-Stats have fan coils, fan power box, just regular boxes, isolation rooms. We talked about the isolation room graphics. We talked about all that, okay? All the isolation rooms in every single room that has pressure relationship stuff that we had at Conca has, which is different now, guys, you gotta remember, has a door contact closure. Do you remember the issues we have about 6 West, 614, 600 constantly coming because they leave the door open? All right? Well, we conquered that. We
Yeah,
conquered that by putting door contact closures. If the door is open, we will not get an alarm. If they close the door, and it still doesn't have its right pressure relationship, then we'll get an alarm. So when you truly get an alarm, you understand that it is an alarm. So when we're actually responding, it's because the door's closed and we lost pressures in the room, okay? That's an
No longer a
enhancement.
phone call, right?
You wanna add something?
Yes, a number of the rooms have the little the short side door. You got the main door for the, but if you're bringing the bed in, you gotta open up the additional space. There's a contact in each of the two doors. So if they decide to prop this small one open,
Yeah.
it also will stop the alarm from coming in.
Okay.
You gotta understand,
Great.
pressure monitoring through sectors and all that stuff are only as good as the box, that's the tight box that's formed to have that pressure relationship to its outside adjacent spaces. Meaning, you can't have a pressure sensor in this room and have that door wide open. It won't maintain pressure. You have to close it, have a sealed box, then you monitor it. So if that box is breached in any way by doors open, then you're gonna lose pressure. You don't need alarming. Okay? That's why we did it. That helps us because of all the things we had up there at 600 and 614.
Yeah.
I'm gonna go back and I'm gonna get that, guys. I think that's gonna be on my list for this year. To attack that one again, see how I can modify that and get that from the
Right.
stopping.
Yeah, it is.
It's
It
nuisance.
is a nuisance.
It's a nuisance. All right.
You've got a cab heater there in the stairway that's unique on this floor. It's not on every floor, so
What is it?
a cab unit heater right here, yeah.
Yep.
Oh, they call it a fan.
There you go.
So it only heats. So, yeah.
It's a heating only unit for the floor. Okay.
The stairway.
I'm gonna move up.
What's that in 229?
Where
I
I-
missed it already? Room 229?
Just tell me up
In
left.
the middle of the building, right above, yeah. Like
This
right-
here?
Yeah, right there.
Oh.
We should go by that already? Did I
Yes, we
miss
did.
that, or-
Sorry about that. This here is for the plumbing. The plumbing shop requested this, but it's good for us too, just in case they don't know about it. We can help them out. This here is where
Riser.
the riser comes off the floor and it serves domestic water. Okay, plumbing domestic water to the floors. They always wanted to know because if they ever have recirc problems, they want to know whether the water leaving, the water returning. So if you clicked on that, brings this screen up. So he's going to highlight the first floor so you know you're looking at the first floor. It'll tell you the temperature of the domestic hot water, temperature coming off the floor. There's a adjustable. We can adjust them. Timmy can tell us what he wants them at. We can adjust them. That if it's too high, the temperature's too high, something's overrunning, we'll know that. If it's low, Timmy's got to tell us. If it's low, we'll make adjustments and he can know. He wants to know if the temperature falls below 110 degrees. Supply water, they want to know about it. All right? Domestic cold water. The cold water, which they want to know is, but they want to know whether or not there's a cross tie. If something happens, all of a sudden domestic water goes up higher than something else on the floor, they know that something's cross-fed. So they want to know the temperature of the domestic cold water, and they want the same things, high and low temperature set points. So they'll know if there's a cross thing. It'll alert them that something is cross-fed. Recirculating, that's recirc hot water coming back. They want to know the same thing, recirc hot water coming back to the domestic hot water. That's domestic hot water. This is domestic hot water recirc. Okay? You guys know how that works, right? We feed the hot water up the building, it returns back down to the heater, and we keep the loop hot. He wants to know about that. If that recirc water, if it gets cross-fed and it's coming back way low, and this gets warmer, we know there's a potential cross-feed somewhere. Troubleshooting tool for him, okay? That's a screen that's going to be very useful for the plumbing shop to diagnose any of the recirc water issues. We're also going to be including a riser diagram. So you'll see this in a riser format, not just a blank screen. So you can look at the building and see the runoff takes on each one. Okay? That's what that's all about.
That'll be
Good
good for
catch.
us off-shift guys too.
Yes.
To really determine if we have a major problem to call Johnny or one
Yeah.
of the bad plumbers.
Okay?
Especially up here, because most of the plumbers don't know how to get in and see what the graphics.
Right.
So you, as long as you know.
They might ask you to go in and
We
say,
may not know-
"Here it is."
We
Yeah.
may not know where all the manual
Yeah.
temperature, in some of the older buildings are.
All right.
So, that'd be good, yeah.
So we talked about that. We talked about the air handler serving the flow. We talked about the UPSing. And let me go back to that. Each floor has this little symbol. That's your UPS for the first floor. Okay? You click on that, it brings you to the same screen showing you that you UPS on level 1 there. And that's the one there. Okay? We're gonna go up to 2. Second floor. Same, all the different features will all be the same on this floor that we talked about. Stairwell, that's the same stairwell unit going through here. Hyperlink it over the main building, second floor, okay, which is gonna be puffed and buffed and made sure that's up to speed and good stuff. The only difference on this floor, this program space. If you look around the graphic here, all right, you got the domestic water riser, again, those feeds that we just talked about. MRI. We open up, now this is the second floor MRI suite, all right? So I have, help me out, Jamie, 2208,
Yep.
228.1.
Yeah,
These the
the-
rooms?
08.1 is on the right there. I just couldn't get that data in there, or relatively, so I just put the room number. Yes, that's the supply and exhaust for those areas.
So I understand because I have to understand this now. 2208 is the room that it's in. This is this room here, 2208 room.
Yep.
You're telling me that there's a VAV box. This is the information off a VAV box.
Right, you can actually click on the T-stat right next to it,
Mm-hmm.
and it should take you
It's going to take me the same information.
right to give you the max and the mins on the set point, and the typical box information. This again is more of an overview.
Okay. That's the box serving that room.
Right.
Where's my room number here?
It's not there yet. We've still got the box numbers in there for reference at the moment.
You're going to change them, Lo?
Yeah.
Make sure you know that. You're going to write that down.
We definitely know that.
Okay. So.
Right now, we just wanna make sure we have them there for relationships back and forth, and
Right.
balancing as well as addressing is on screens, yeah.
Okay, thank you. So, go back to this one. So that shows that the discharge air temperature of the box, 67. Space temperature is that. It's maintaining. Space temp set point there. Flows, all that kind of good stuff. Reheats, exhaust flow. So it also has an exhaust box associated with this. Differential flow set point, 0. So there's no relationship but what's ins and outs.
Neutral.
It's a
Whatever
neutral.
the supply does, the exhaust matches.
And if we wanted to change it, we could exhaust if we wanted to.
You could make it a negative number
Or a
negative
positive-
room or a positive
positive
room
room.
by changing that.
That's good to know, right? All right. So this one here, 2208, takes care of this area, and then this here, information is based on this room here, inside here. Is this okay for everybody? Is this going to be confusing to everybody?
I'm okay.
We walk around here 3 months from now and go back to this graphic because people can understand that this information goes here.
I would hope so.
All right. And then we have a CACU Liebert unit in here, and they're working on this long connection, I'm assuming.
I have the 7th floor data online,
Okay.
so when you get
Is
there.
there gonna be water on the floor sensor in there too?
There is, there's 1 or 2 of them in that room.
Can they show it on that graphic?
Yep.
Like,
Yeah.
like in the basement?
Okay. Good idea.
Yeah, I think they're integral with the crack in it, right?
Well, there's also one for the unit itself to shut it down.
Not what you monitor though, is it?
It
You
would-
don't monitor it.
That would create a common alarm for your crack units,
That's what I'm
yeah,
saying, so
yeah.
it's part of the crack in it.
Yeah,
a lot of-
yeah. But we also have the Drexelbrook,
Oh, you have
I'm
your
trying to
own- you have
picture
your
that
own
room, I
too,
wanna
okay.
say there's 2, there's one in each corner, but it may just be one,
Okay, so the crack unit has one and then you have your own.
yes.
So I would get into the suite. I'd come through this doorway right here into this space. I'd see this would be the box that's serving and exhausting this space in here. That's what I'm reading. Then the CAC of the Liebert unit back here to support the MRI is through this door here. You come through here, and this is an area that the Liebert unit sits in, and we'll have information on that. That's supporting the MRI. And then this is the MRI entrance doors with the wave guides. You walk into the MRI here, and this is where the MRI machine is. So in here, we have exhaust fan 16 override. Fan status is off, fan amps is 1. I'm assuming this strictly is for the purge.
Mm-hmm.
That's correct.
So exhaust fan 16 is for the purge system. So there's an O2 meter on the wall, okay, measuring oxygen depletion. If oxygen falls below, I think it's 19.5 or something like that, 19 or 18.7.
19.5.
It's 19.5? Oh, I was right the first time. 19.5. If it falls below that, this meter will go into alarm. Will this turn red?
Mm-hmm.
Okay. This will show an indication that it's gone into alarm.
And an
That
alarm
will-
will come to the graph.
Yeah, to operation center. This purge system, is that a button that if the
There's
purge
a
button?
manual switch on the wall.
So,
So somebody in that room
Can activate.
can actually activate it by turning the
Right.
switch.
Now, if the O2 goes off, will they both go off, or this will go off only?
Just
But
the
if
O2 will go, the O2 and the purge are two separate points.
good,
So if it trips based on oxygen depletion, that will go red. If somebody turns the hand switch,
That-
then
that'll
the
go
purge
red.
will go.
so depending on if it's an automated process through the meter, that starts this purge exhaust system. Okay, and I'm trying to remember because I don't know if from this graphic it tells me that, but the exhaust purge system is supposed to start the exhaust, close the return damper,
And open the exhaust.
right, and open the supply, or close the supply.
There's an exhaust damper that's in there that's normally closed.
So yeah, right. So the
That's-
exhaust damper and exhaust fan starts.
Right, there's a damper on the return.
Yeah.
Like a Belimo on the return, and there's a Belimo on the exhaust. When it goes into a purge mode, it closes the return.
Right.
Belimo.
Mhm.
That normally open damper closes, and then the normally closed damper on the exhaust will open up to exhaust it out through the exhaust fan.
Yeah, the supply stays alone, stays the same.
Yes.
Okay. How with you telling me that? Show me here how that what changes here. How does this change during that? When that goes off, what do I see? Do
All
I
you're
see
gonna
this
is the fan status come on, you'll see amperage.
on
the,
amps?
The dampers are electrically, it's all electrically driven. There's no interaction as far as us with the dampers. They're part of the
It's all
electrical
hard,
circuit.
it's all hardwired, there's
hardwired
no
circuit.
automation interface to them at all, they're interfaced with the fan. Even if you were to walk up to the fan and put it in the hand at the starter, it's gonna position as dampers, it's gonna start it.
So my isn't this return right here? It says return.
That's your return VAV box.
Right.
Yep.
So my return VAV box, I'm assuming I don't have damper positioning on my VAV box. Okay. My exhaust flow should go to 0 then? Return flow?
Yes.
If the damper is closed in your exhaust flow, you're not gonna have any change across the measuring station, so it should go to 0, yeah.
So that's what I'm saying. So if you need to look at this to say if that goes on, what you should see is the exhaust fan command to on, which would you have to make an assumption that the damper open, you see amperage, and you see that return here go to 0. So no more return.
Say return flow from.
Your assumption on
Yeah.
the dampers are gonna, if the dampers don't move, the fan's not gonna start.
Right.
So, I mean, there's your assumption that the damper's opened, because if the fan is running, then the damper's opened. If they're not running, if they're not open, then the fan isn't gonna run. So that's another way to look at it also.
I'm just trying to. I want to make sure that that's a good point. This should say instead of exhaust, it should say return flow. So return flow should go to 0,
That's a good point.
right? Differential flow set point should it's constant volume, so it doesn't matter what that does. And the exhaust flow set point these two should go to 0.
The set point.
Oh,
will
the
stay
set point will stay the same.
It's gonna keep trying to do its deal, but you're choking it off when you go to the
So-
approach condition.
This should all say return instead of exhaust,
Yep. that's right.
and that should go to 0, and that should go on when that's an alarm here or that's an alarm.
So this is the three ways you can get the system to run: purge, O2, or a manual command by you guys.
Override right here.
Yes,
I can override that, and that should start this up,
yes.
and this should always go to 0.
Well, I'm gonna say that it's gonna drop off significantly. I mean, if the damper has leak by or whatever.
Oh, yeah,
so,
yeah, you
know,
know what I'm
I mean,
talking
you
about.
might
It's gonna-
get-
it's gonna-
you might get
Can we
some
do that?
flow
Can we
through it.
initiate that right now?
Yeah, that's what I was wondering.
Well,
Override that if you like, right there.
You wanna try it?
Yeah.
No?
Okay.
that's an active, not an active, but it's an operating MRI. But no one's probably in there. Let's try it out. See what happens. All right. In case they call you, Frank. So I double click on this, or right click on it.
Are these gonna go right?
I go to
into base
override
right
on.
now?
Is that what I do?
Yep.
Override on, and I hit done.
Yep.
So override's on.
Hopefully no one's standing next to the fan and will scare the shit out of them.
On.
Yeah.
So the fan went on, so that must mean it got damper status. The balance is balancing right now. It's like, what the hell?
Belimo's stroke kinda slow.
Yeah. I'm getting up 45 seconds. Oh Lord.
Looks like that's going up.
Are these alarms still going to construction screen right now?
That's not sound good. Is that gonna be the face?
No.
Now we'll be going nuts. You get all of our alarms.
See, average going up, but I don't see that exhaust flow dropping yet. Return flow.
This is RH valve, that's your humidity valve, correct? It's not a reheat, so it might be worthwhile making it HUM instead of RH.
Yeah, that's a good
Small point, but, you know.
What is it called? What is it?
It's a
RH valve.
humidifier valve.
It could be interpreted as reheat.
Yeah. All right,
It's
right,
relative humidity valve is what
Okay.
it was.
It could be interpreted either way, depending on.
Yeah, let's put that down.
Kind of.
You think you would have had flow drop by now?
Common sense.
I would've
will
thought
tell you.
so. I would've thought that you would've dropped out of the your exhaust flow would've came down.
Can you write down a list and see if we can check it out? Write down, see if we check it out, and then we'll come back and then we'll bring it up and we'll override it again and see it happen. Okay, I'm gonna put this back now
Yeah,
because
put that
it doesn't look like it's, you know, that should have dropped, unless it's looking at something else. But all right,
I would've thought it would've dropped myself.
all right.
Go back to NA.
Yeah, if you just put that in.
NCI.
Yeah.
Set in.
down the
Right here?
bottom, Yeah.
Beautiful, yep.
Okay.
What does this NCI stand for?
That just puts it
Clear.
in the auto mode.
It's like auto, yeah, it's like auto.
All right,
I
well-
think it was a handoff auto.
Something we're gonna do there. Okay, next is anything else in this room now? Humidity isolation valve outside air lockout is 60 degrees.
Yeah, that's a, the second floor and the seventh floor, the Meg room doesn't have it, but the seventh floor in this particular floor, they ended up putting in an isolation valve. So you have your humidifier valve that's gonna modulate to maintain humidity in the space. They put a Belimo two-position isolation valve on the steam line that feeds the humidifier. When the outside air goes above 60 degrees, it closes this isolation valve and it isolates steam, it prevents steam going.
Is it this thing here?
Yes, that would be the whole, that's on the return, yeah, so that would be your reheat valve, yes.
So that's.
So they're gonna shut off the valve?
Hold on a minute.
Shut off the steam.
So-
Shut the steam off.
I was told
They're
that
not
you're gonna
worried about
change
it
this
flooding?
word,
To humidity.
humidity.
Or
The
So
the humidifier
this
system.
statement is pertaining to this. Can we
No,
just?
That's the command of what so right now, the humidity inside the space is 50%, the set point is 45.
Right.
So right now, the valve would be closed,
Right.
because based on set point to humidity. But as far as the isolation valve goes, I'm gonna assume that if you raise your humidity set point above 50, that valve is gonna try to open regardless if that steam isolation valve is closed. If you want.
So it's going to override this. So based on this, you've got
It's
outside
not
air of
gonna override
65. At
No,
65, it's saying that valve's closed. It's locked out.
No,
No.
There's two locking valve on
It's
there.
two valves.
two valves.
It
two
doesn't show the
valves.
status of the blocking valve on the screen though. The two-position valve
Yeah.
status is not shown on here.
There's two valves, there's a modulating reheat valve, and then there's like a two-position isolation valve.
Can someone draw it? I don't understand that.
Oh, the valve itself.
Why don't we put, Steve, what if we put humidity isolation valve lockout at 60 degrees? And then right under that statement,
Show the-
valve locked or unlocked.
Yeah,
It's,
show the status of
position.
the valve, yeah.
valve is
Open or
either,
closed.
Open
isn't
or
it
closed.
open or closed?
Yeah.
Yeah.
So that way there, if it's,
So, but.
if that valve's closed, it doesn't matter what those readings say for humidity thing, you're not gonna control humidity. You're not controlling humidity
Above 60.
above 60 degrees. And the way that you tell is, see the outside air temp up in the right-hand corner? If it's 65,
No, if it's-
that valve, hold on a minute, that valve should be closed,
Locked out, yep.
locked out. It should be in the off position. If it's not, then there's a problem too. There's something's telling it not to do that. So then when that valve is open, you can change set points and you can actually control that valve, regardless of the humidity valve percentage below modulating itself doing nothing.
Exactly.
Did I get it right?
Yep.
Go ahead, Mike.
Now, aren't you gonna be concerned about having any condensate collecting in that line and when you first start up? having moisture come down into that, through that humidifier? No?
Sounds like a question for a plumber.
You're talking about,
If it's isolated for
Yeah,
the
yeah.
summer and we go to, when we start to use it and there's condensate in that line, you send in that sitting liquid in that pipe downstream and you're pushing it through that humidifier, like, you don't want anything dropping out and getting any moisture in that room. Yeah, how are we verifying that it actually is gonna flash into a steam form coming out? That's something that I'd be concerned about.
well, we're gonna find out soon enough, but it looks like we have enough equipment to go by if it does happen, that we have enough to go by to say, okay, command that, override that lockout all the time open. Don't use it.
It'd be no different than if the humidifier wasn't calling.
That's
or
right,
something.
exactly.
Yeah,
You're in the same position.
I guess you're right.
So, but no, it's great features. Jamie, you got enough to go by to make those tweaks that we need
Mm-hmm.
to make this sense? Okay, so we didn't go down and see the supply. The supply discharge air, that's just a VAV box supplying air into that space. One of the things we have on here, and I want to point out
Is that the VA, is that, what's the one on the bottom left here? Is that another box out in the open area? 2008, this one on the left bottom?
that's
on the
just where
graphic?
that's just where the words go. But I don't believe that's part of this MRI suite. I think that's outside the suite.
There
That's
is
my
a short-
assumption.
There is a short corridor there, at the very bottom left of the MRI suite.
Mhm.
And I think there are two boxes in that general area. It's a large
2208.
area.
That car, where it sits that car right there.
See this slide on the bottom left hand
Well,
corner?
yeah,
So
Probably
that's-
just for that little stretch of corridor there.
So what
Okay.
I would suggest.
You talking this here or just here?
Yeah, that one right there.
Right
Yeah,
here?
Is that a second
Well,
box?
there must be some kind of room number associated with that, right? Like C1, something like that. You may want to.
Well, let's do this. We'll go back to the big floor plate, and we'll see that. We should be able to see that in the big floor plate. How that laid out. One of the things that I want to make sure as when you looked at this, each one of these penetrations has a waveguard. Anything that goes through has a waveguard. Those waveguards have access to them to be cleaned. Remember we talked about that? So what we'll end up doing is when you see these penetrations come through, Jamie,
Mm-hmm.
can you put a little tiny thing called waveguard? And waveguard. So people understand there's waveguards in there.
Those-
Supply I'm not really worried about, even though there's a waveguard there. I'm worried about the
Especially the return.
one of the things we don't
How
know.
they get all dusty and everything
They
and plugged up?
get clogged up. They're
One
like,
thing-
they're like a honeycomb.
Yeah.
They're like a honeycomb thing.
Let me ask you this,
Mhm.
Jimmy. From this graphic, I don't know how accurate this is.
Not wicked accurate.
Is this the exhaust over here and the returns over here? Supplies over here in the room? Do you remember, Steve, at all? You guys
No, that
remember
is
this at all?
not. That is not the case.
No, the return comes out around where that angled wall is. The return leaves the room there. There's a VAV box just outside that door.
Yeah, in order to get them in the room,
Picture-wise?
yeah, so that the information fit, it needed to be reversed.
What I think I'll end up doing is when I get the, I have the construction documents. One of the things we'll end up doing, just to let you know, is that a lot of these graphic screens, when I'm going to link things to a folder, I want question marks.
Mm-hmm.
So like this one here, I'll have a question. So you click on that, it'll bring you right to the as-built in construction document, the design construction documents. So that way there you can look at to say, oh, well that's how they put it. Oh, here's the as-built. Now I can actually see how it's actually constructed. You know what I mean?
Mm-hmm.
So make sure any of these graphics have that question mark on there, so I can fill in the folders, books.
Yep.
Jimmy, that's something we'll be doing. You'll be doing, helping out, filling in the drawings and all that stuff in the
Alright.
folder books. Okay. All right. So I want to go back real quick, and we'll answer this question that Mark had real quick. Here's the floor plate drawing. So it looks like this is the stairwell. You were seeing pieces of the stairwell here, Mark. See what I mean? Here's the corridor going in. Here's the room. He blew this up, but see this line? That's the stairwell. You follow? You guys ever get that?
Yeah, so that VAV box is doing that little stretch of corridor.
Yeah,
outside
it's-
the OR.
you know,
Alright.
It's
That's a big area.
so none of this in this graphic screen. You might be able to even take this and maybe, But he needed it for information. None of this area is
No,
associated
yeah.
with this here.
Yeah.
Okay? That's actually the stairwell.
It's just a shape
And a
of
closet.
Just that room shaped that way, and
Yeah.
there's two boxes.
Right. Okay? Now, over here, anybody, can we move on from here? Everybody want to move on?
The supply box is outside the room, correct?
No boxes are inside the MRI room.
Okay.
I can tell you right now. Only ductwork and diffusers are. Any boxes are outside this area.
As far as just for representation, the thermostat is for the MRI is on the door. It's actually on the other side of the wall, but
Right.
just so as far as if there was no confusion, it's placed on the inside of the graphic, so you're not.
So we know it's
you know
controlled
it's
from
controlled
the
Yeah.
inside.
that one.
All this is actually out here.
Right, that
Yeah.
physical thermostat is on
Yeah.
that wall where Steve has the mouse pointed right
Right.
now.
Okay,
Okay?
fine.
Alrighty. Okay, I'm going to move on to the water side. Now, each MRI, as you know, has a shield cooling system. So we have to provide the the shield cooling stuff, and I'm assuming it's in here. Help me out, Steve, if you know about
Yes, that all of the.
All this water that's supplied here goes into this room.
For that, actually, that shield cooling system supports the other MRI as well. It's,
Right.
that's your- yeah, oh, okay, yeah.
For this graphic.
Yeah,
Yes.
yes, that's true.
So, if this here, and here, that's these to and froms are actually going to from this room here. It's fed in here. Do you think you might be able to figure something out there, Jamie? Maybe a thin little line coming up here and going in and putting dots here or something to show
Yeah,
ins and out of this
okay.
room? Because that's really where it's going. It's serving this chill water is going into this room here, serving these units in here to serve these MRI. Instead of seeing it here. You know what I mean? Does that make sense to everybody?
Now, where the heat exchanger 5 and 6, where are those located?
Those are located in the fourth floor.
Maybe
Yeah.
you wanna put, maybe you wanna put a note like
No, yeah.
We-
something up there saying you're located.
Maybe right above here?
Just,
Yeah,
just so you know
shows
where they
down
are.
to room.
Is that the
Something,
strain
so-
that you have to get to
Yeah.
with Joe Colonna?
I know.
So right above that heat exchanger flow, just say heat exchanger system located in BB fourth floor,
True.
mechanical, whatever. All right? And then we know where it's located, how it's getting all this system, and then how it pipes down here and goes up and serves this room. Okay? So with that being said, we maintain a system up on 4, and we have the chilled water supply and return, processed chilled water. This water coming into the heat exchanger is off our building chill water or Maytemp. It's primary. And then secondary comes off this and serves medical grade, clean, processed chilled water going down to this MRI and an MRI up on 7. Okay? So it's a dual system. It has pumps, differential pressure valves, DP set points and sensors going through, and all this kind of business here for the Lamy. This is just a quick reference to let you guys know where that comes from. There is a greater graphic of this when we go to the 4th floor. Okay? This just gives you a good reference of what's going on. When you have a problem here to sit there, you can go to one graphic, look at airflow and water real quick to say whether or not I have a water problem going to this MRI, this room here, serving this MRI. Okay?
Is one heat exchanger only online at a time, or they're both running together?
It's just one heat exchanger.
So this one's online right here, if I had to
And the
guess.
other ones are-
The other one's for the 7th floor, right over the common. The common.
They're common, it's one big loop system.
So one's in standby and one's online,
Speed lag, yeah.
correct?
Well, the heat exchangers, I to be honest with you, I know that the pumps will lead lag, they'll alternate based on a rotate schedule. As far as the heat exchangers go, I'd have to check them and see if they're.
Might be a
isolated.
manual.
We don't physically have any isolation valves that switch one heat exchanger to another. So if it's gonna be something, it's gonna be a manually switched type valve off type heat exchanger setup.
Well, let us know that, because then when we go to the 4th floor graphic of the water thing, we can put that right on there.
Kinda
That's a
looks like-
manual
kinda looks like
changeover
they're
for
both
heat
online.
exchanger.
I think-
That's what I'm
I think
saying.
that
They're all
they're,
reading
you know,
low they're all reading pretty low temperatures.
everything's probably open, but you can
Yeah.
obviously manually
They all got
valve them
low-
off. There's
they all
no
got low
isolation valves to
temperatures.
isolate one, like automation
Right,
wise.
and there's no Belimos in there, they're just regular hand
Same-
shut
and
off,
all
chain
heat
valves.
exchangers in here. Heat exchanger 1, 2, and 3, same thing. It's all manually done.
Excellent. So we'll get some more information back to you and all that stuff, and then we'll get to the other graphics. We'll enhance those if we have to. Just put some words in there to help us out understand that. And these are the pumps, P4 and P3. Here's the pumps 4 and 3, so it looks like 4 is operating, and 3 is in standby. All right, differential pressures, differential valve. I'm assuming that's 0% open. That means it's not open at all.
0% bypass.
0% bypass. So we're not bypassing, we're pumping everything down, and we're returning everything. And we're trying to maintain a differential pressure of, where's the set point?
I'm gonna assume it's
Is
on
that,
the main.
is that the other big screen? Okay, so this is just a reference screen. We'll get more details about that from the other screen.
Which you can get from here if
Yeah.
you needed to.
The top left transfer switch to the,
If you needed to go to this system, here, boom, that's the big one, okay? This is showing now up in the 4th floor. So you get now your primary, you can check out your primary going to everything, okay?
Alarms, alarm set points.
Heat exchangers, you have all your temperature ranges for your primary here. So this here is like a dividing line. Everything on this side, over here, is primary, May temp / our chilled water plant. Everything on this side of the heat exchanger is a closed loop pumps system, cleaned and treated, filtered, and delivered to 2 MRIs. You know what I mean? On this graphic here, I can tell you right now, Jamie, for here.
Mm-hmm.
Just
To
put-
and from.
Yeah, you could put 2
Two
MRI second floor,
and
MRI 7th floor. Return from, same thing, return from those 2 floors. And then Jim Kirby asked that you right up here, which makes sense, just Biddy Street, 4th floor.
Mm-hmm.
So it just tells us where the stuff is when we're looking at them.
It's the Ryan Rizzo filter screen around.
Okay.
Hey, Joe,
So-
hey, Joe.
Stepping through this, we've got processed chilled water. Is that the set point?
Those are alarm set points.
Alarm set point. So we have high alarm, low alarm, and it's maintaining what it's maintaining.
See right below 57 Binny on the
Do you want
top?
the set
That's
points?
your set point up there for the water.
60.
Up here.
Yes.
So
What?
this here, we're trying to maintain a set point of 48 degrees over here. That's what I'm trying to hear?
Mhm.
So we're trying to maintain 48 degrees, that's our set point, of processed chilled water to the MRIs. Is this a good location for this, guy?
That was on the other graphic as well.
Or do you feel like you want to put this over here to show that it's going out and this is what you're trying to maintain out here? Is that better or
And
no?
up top there, you should have the low alarm set point. I thought that SP was the set point for the low alarm at first.
Low line set point is right here.
Oh, okay.
It's on
that is
0.
the 0, I'm getting old.
So that's
Yeah, you
adjustable.
could move it away though. You could
How,
move it away.
does it, no, I'm just saying, because it kind of threw me for a loop to say that we're trying to maintain this loop here. What we're trying to maintain, it's up here.
that's where it's located though, so you.
Yeah, I think that's where the sensors located
Sensors.
in the system, I think that's why.
It's
they put it
located up
there.
here.
Yeah,
Yeah, cause it would be.
if you were to go up and look at the piping, you would be looking, if you showed it somewhere else, you'd be looking for it somewhere else, it wouldn't
Yeah.
be there when you got
Okay.
there.
Yeah, that's why I think they did it that way.
Everybody okay with that then?
Yeah, it's probably better off there, I guess.
Everybody the way that it's
Yeah, 'cause
put
then you
together
can-
is good?
Cause then you know where what sensor is actually controlling the temperature, it's better there.
Yeah. Now, is this, we're over here, are we trying to do the same thing on this side?
No, those are just, that water that's
Alarm
coming in
set
is your water coming in. The,
We're not trying to control anything here?
No, the only thing is,
Monitored.
Maintain?
yeah, that, not well, the deny.
Well,
the
deny
It's
valve.
monitored, that's
The
all.
deny valve's being controlled by the other separate.
right,
The deny valve?
that denied valve, you see that's
Right here?
23%
Yeah.
open, that's what's controlling
That's
to
open and closed
maintain
and to
that
maintain the
temperature on
set
the
point.
right.
Off this?
Maintain that.
Yes.
So this here is controlling that valve
Yeah,
to open and close to keep up, to get to our 48.
Yeah, everything else is informational only, yeah.
Okay.
For temperature anyway, yeah.
Everybody good with that? Okay. Okay. Then we come down here, now we got pumps. These on schedules?
Yes,
Yeah.
they'll rotate, on the schedule that Jamie has set up.
Okay. And we have overrides on if we need to command them on and off, it overrides them, right? We have 2 pumps. Looks like this pump is on, overrideable there. And then we have this valve here maintaining, this is the same from the other graphic, just a little different. Then we have this one here, it shows the filter racks and the DP across that. These are adjustable too, low and highs.
Do we have a minimum speed that these are gonna default, that they'll keep the MRI going if we have a problem in there? On
And the drive, if the drive fails,
Yeah,
I'm assuming they have 100% bypass and this valve opens up and start rat racing.
Right.
That's my assumption.
okay.
I mean,
Um,
the drives have a minimum speed on them. But
there- it is redundancy.
It's not there to maintain a specific flow, you know, for that. I mean, you know, the ABB drives have a minimum when we get a start command, they go to their minimum flow. Once we get proof, then it starts to modulate up and down. But like
Right.
Steve said, if the DP drops low, your bypass valve is gonna modulate accordingly to try to get your pressure up
Yeah.
in the system.
If you're talking about a failure, that's why you have redundancy, 2 drives, 2 pumps, 2 all that stuff. You'd go to here, you command the other one off, you command the other, if you think there's a problem with the drives and all that stuff. Or if you get into a situation where you have to turn around and you could go into bypass mode, put it at 100% across the line, and that DP, that differential pressure valve is gonna go wide, you know what I mean? Because you get so much DP, it's gonna open. The third thing is if you have a complete failure of this, there is a chill water bypass valve. I don't see it up here. A manual operation valve.
Yeah, the plumbing
Higgins
guys
put
should
it in.
be able to identify where those are for
Right.
you. I'm not sure where they are.
I would love to. It's got to be up here somewhere, right
City
around
water
here.
back up
City
top.
water.
Yeah.
You're talking chill water, you're talking city water.
City
Yeah.
water
City
back.
water back.
So the other thing I tried to do is we have to. I'll find out if we have to get this graphic, and maybe I'll ask you, Robert, to do this
Go ahead.
because you have the graphic screen on this.
Yeah.
Find out where the city water bypass was plugged into this.
Sure,
It might be somewhere in here or something, or right over here.
sure.
And then we can do a bypass from city water to drain, so you guys understand in a complete catastrophe, you can open up city water and go to drain. I think the drain is actually down in the MRI second floor. Yeah, so you go up and open up the city water, you close off the chill water, you go down below and then open it to the drain, so it runs through the piping all the way downstairs and it drains out the bottom. Okay? I'll get that information, because it's good to know. Can we move on?
Yes.
One quick operational question maybe. The pumps, you said are gonna rotate?
Right here,
On a
pump
schedule?
schedule.
Oh, pumps, okay, I just wonder, was it be like once a week or?
Add, close.
Yep.
Schedule.
Plus sign next.
Schedules, and then we drop down and find the pumps.
Yeah,
It's
yeah, 5, 6.
4 or 5, 6. Schedule details. So rotate daily schedule Monday.
Okay.
So every Monday it changes.
Every Monday, okay.
It switches?
Okay.
That 3-minute differential between the two is just give it a pulse and then back it off
Right.
again. But at 8:30, it's gonna swap.
Right. But I mean, this is, we can go in there. We don't like this. We can go in and change it anytime.
I was just curious,
Okay.
how often they're,
All right. I can just close this.
Yep.
So everything's in there for scheduling for different pumps and different chillers and all that kind of good stuff, all right? Okay, so we made it to the second floor. We made it through that MRI screen. Before we move on, there's nothing really else on the screen that we have to go over right now, I don't believe.
You have the radiant panels out there. You may just wanna touch on one of them just to give an idea.
Oh, this?
Yeah, your overhangs, yeah.
All right, well, you're gonna have to put radiant panel overhang some word here. Tell me what that is. I didn't know what this stuff was hanging out here.
Yeah.
So what's this called? Is this radiant panel overhang?
I'm not
Benny?
sure what you wanna call it, but that's what it's serving is a heating element that's in the overhang to keep the piping from freezing and
All
inside
right,
those enclosures.
we'll call it Binney Street.
It's
Is
a-
it considered a radiant panel
It's, I think it's
or heating?
It's been
Binney.
radiation inside those spaces.
I think that's a glycol system.
Okay, we're getting closer.
It is glycol.
So it's
right, yeah.
Binney Street
Glycol.
Glycol
It's fin, you say it's fin tube?
Yes.
fin tube
Yeah,
heat.
yeah, fin tube, yeah.
Okay, right next to the 67 up there, and the 66,
And
Yes.
66.
and the 67.
Yeah, and that little
Three,
alcove
it's
down
three.
there.
Just put it with 3 lines pointing to those 3.
I could do. You can do that.
Wording ones.
All right. So put those up there so we know what that is.
Like a bracket.
Shotgun.
Alrighty, click on that, and it should bring me to the glycol system. Something to do with this. All right, here we go. Binney Street fin tube radiation. Oh, you already know that. To get to put that word on the graphic there. It's probably in the legend, I bet, but.
It's not yet, but it will be.
Anyway, so then we look at that, and we see that we're looking at BB, fin tube radiation, 0233, space is 67, temp. Is that what we want to maintain?
Space temp and then set point in black.
Now, that
So,
system does not energize until it gets below a certain temp outside, so if your heat exchanger is not pumping any water to you, you can open it, but it won't make a lot of difference.
I'm just trying to figure this graphic out here. I'll read it now. So this one, we're looking at this one. The base temp is 67. That's what currently is out there by the sensor.
Yep.
The set point, the minimum set point.
Well, no, there's two titles there. He's got see the unit heaters are up top, you got a title section for the unit heaters, and then you've got your fin tube radiation. I'm sorry, you've got one set of fin tube radiation in the first two lines, then you've got a separate section below that with a whole set of titles, and it gives you a unit space temp set point, it's not a set point, yeah.
See that?
So what's this here? I'll start from the top then. What are
Sure.
these?
On the
Seventh
seventh floor, you
floor?
have dedicated fin tube radiation inside of rooms with space thermostats, and you have a min and max set point for those temperature settings.
In these particular rooms?
No,
Yeah,
two
Seven-
rooms on the seventh floor, there's
Like
two
a
rooms
plumber,
up there.
like a janitor's closet,
I
Yeah,
think
like
it's
a couple-
it's a
couple
long hallway, I think,
a couple of
behind the
small rooms up
elevators.
there.
I think those are the ones behind the elevators, Dave.
Okay. Are these the room numbers from?
On the
No,
right
those
side.
Okay, so 703. These are the rooms that it's serving,
Mhm.
and it shows us
So
that
before we can-
the space temperature. Is that space temp?
Yes,
Yeah,
then you have your min and max set point, so the person could change the temperature setting, but only between those limits.
So it's 7 degrees
Those
in
two
there.
aren't behind the elevators, that's a
no,
plumb.
yeah, that's something.
Those are a janitor's closet. When you come off the elevators, when you come off and you go left, you can go to the right to the bridge, that go to the connection piece that goes
Yeah.
to the hospital. That's one of those, and then right after you go across from like that meg room, there's another room right there, that's the other one right there. Like Steve said, you have the space temperature and you have a min-max. They can adjust the range of their set point, what they want inside that space between 78 and 68.
Who can adjust? They can adjust by the
occupant
thermostat?
of the room, by the thermostat.
Oh, there's a thermostat setting.
Yeah.
Just
And
for
these are the
first two
limits?
lines, yeah.
And these are the limits they can do?
Yeah.
Okay.
There's only a couple in the building, so it's just a way to identify it. When you get on the floor and you click on the T-stat, you get the same screens, just showing you what
What's the difference between that and that?
That's what's on the sensor.
That's your resultant set point on the temperature, thermostat is 70 degrees, your actual space temp is 70.
So it's right. It's just dead nuts right on.
It
then.
is,
Right
yeah,
on.
yeah.
That's right.
Perfect.
So
Great
if
info.
my
Good job.
space, so my space, is this just telling me what the temperature in the room is?
Yes, it is.
This is telling me my high point,
Yep.
low.
Yep.
This is telling me what the occupant set it for on the thermostat.
Yes.
And then your valve position.
This is telling me it's open 12% or closed 12%. Is it open?
12%. yeah.
Open 12%. And
Those two rooms, they're not on the glycol, right? They're on the regular wall.
Yes,
Water, yeah.
They're on the regular wall.
Regular.
So they're not affected by that radiation lockup?
No.
No, because,
Just,
no,
Right.
just it.
because that's your only form of conditioning in that space, is a radiator. It's a simple radiator, it's, maybe a radiant panel, but it's.
Yeah.
I'm just kind of a little confused why it seems like I got commingled stuff here.
No, I don't
Trying to
know.
figure this out.
I was on the glycol picture.
So, because when I did the glycol thing, it came to this. Why did we carve out that fin tube radiation this way? Just so I
I
understand.
dropped all the fin tube radiation together
Oh,
in the
okay.
entire building,
That's what, okay.
regardless of.
And if it was glycol or hot water.
But I can definitely break it out a little bit more. Say some are on regular water, some are on glycol.
I definitely
or I
want to
can pull
separate
out-
regular water glycol. Like if I pop open something glycol, I want to see all the glycol stuff. That's definitely a good thing. But I don't want to. It's too confusing to remember that I'm looking at
Mhm.
glycols and regular waters and no regular. There's no way for me to.
Some's not.
Yeah, there's no way for me to tell. So, is this block here of information glycol, or we don't know that right now? All this.
I don't know if 6, 8, and 10, Frank,
All right.
are those on the glycol?
6, 8, and 10 are not red glycol.
So why don't we do this? Take a crack at
What do you
it.
think?
Break out glycol.
Mhm.
So anything you click on glycol can bring you to a glycol screen to say this is all glycol. You can label it right there. It's coming off the glycol heat. Anything that's now on base fin tube radiation that's on hot water heating,
Yeah, regular building hot.
regular building hot water heating, you can carve that out with that and put it under its own thing. Okay.
The only thing that's on the glycol is the 2 unit heaters in the void and the radiation that's above the ramp. The rest of it should just be heating hot water. That's what they explained to us.
Okay.
Yeah, that's what we're trying to break.
That's what we're trying to break it up.
But
Yeah, we don't
this
know.
has a mixer in there
I
on that
understand,
screen.
I understand.
Okay. So why don't you do that and we'll take a peek at that. Okay. I'm not even gonna go through this right now because it's a little bit too confusing right now. But I understand that, but at least we'll put the glycol information. Anything that's glycol, click on that, we'll bring you to that glycol business. Anything that hot water related for stuff, I'm assuming when you clicked on that room, if we went up to and clicked on the T-stat, it will bring you to that radiation one, a radiation screen. Okay. Good. Alrighty, I'm gonna move on. 3rd floor. Oh, wait a minute. Wait a minute. I gotta go back here. Whoops. 2nd floor. I didn't click on this one. Okay. So with that one there, we have UPSing. I'm assuming that one there. That's the UPS. Okay. 2nd floor, good.
20 minutes.
We have our flow measuring then. AHU return. Supply to floor, total exhaust. Those are the totals there. But no exhaust, huh? 0 exhaust on the 2nd floor?
Exhaust fan?
Yeah, there's no exhaust on the 2nd floor?
I'm sure that there's meant to be a flow station that's missed.
I think there's
Well,
one,
but-
like exhaust fan 14 that didn't get dropped on here.
Okay. So just put that as a note, that 2nd floor exhaust.
And the purge fan, correct, for the MRI. It's not on that screen either, but it's on the other one.
That's a good point.
What happened again?
The MRI, you were saying the MRI purge exhaust?
Purge fan's
is
not on there, but it's on the other screen.
Exhaust fan 16.
Exhaust fan 16 airflow.
Yeah, which would probably just,
That's the level 2 MRI, correct?
I think you'd put a dot there and bring that out, Jamie, like this, and put
At-
on exhaust fan 16. It's at 0
At
unless you're
this
purged.
point, there is no airflow station
On 16?
on 16.
Okay. Then we don't need to put it on there. It's not a normal system. It's not going to be normally running. We're looking for normal, but I something
There's gotta be something on that floor.
is
I'm pretty sure it's exhaust fan 14.
Okay.
I have the
Toilet
value,
exhaust,
it's just not on the graphic.
okay.
Yeah, toilet exhaust.
Yeah.
That would be good.
Okay. And then hopefully that when we look at that, these numbers make sense. Because AHU in supply 8, supply B, tells me it's like 3,000 CFM supply, which is that. And then I got a total return of 5,000 and that tells me that like we're incredibly negative on the 2nd floor. So like I think refers back to what you're talking about, Frank, when you
Yeah, I
measure
mean,
stuff and you
the balance is
recalculate.
just starting to go through and
All right.
reverse the ducts.
This was not on the high end of his priority list because it really didn't affect his balance report. This was for us only, not us, but I mean for the automation system.
Okay.
So
There's,
I think it was something he left towards the end of his process,
All right.
yeah.
there's a thing that calls for a construction exhaust for each floor,
Mhm.
and there's another one that's for isolation, but this level doesn't have an isolation.
And I don't think construction blocks we monitor flow either.
I think you might have one, I
We have
don't know
an
if you
F-truck?
have, I don't know if you have one on the unit. When you go to the exhaust fan graphic, it might be next to it if that's the case, but,
I mean, not each
by
floor,
floor,
not by
not by
floor.
floor.
That's what I mean. So it's not affecting
one
this
total,
graphic.
Right.
Yeah.
Okay. Alrighty. So,
You get it up on
yeah, buffer unit. 3. So on 3rd floor, looking around here, I don't know if there's any specialty things going on or specialty rooms.
All of those rooms with question marks are patient rooms,
Okay.
and they would also signify some sort of an AV reg. If you
Okay.
click on a T-stat there, it gives you part of the AV regs on the top right. There could be a pressure and an air change that I'll end up adding
Okay,
to this graphic. But, you know, that's where you're gonna find that sort of, wherever there's a question mark, you should have the AV regs. Cause they're patient names.
okay. Everybody understand that? What I was talking about? Not all, what we had to end up doing is that if there was a program or a patient room or some kind of room that required air ventilation, air regulation stuff that we do, like in these cath labs and all this other kind of stuff, measuring stuff, there'll be an enhancement to that process by this quick reference guide up the top. I'm assuming from there we'll be doing the air
The regulations is right on the main screen.
on the main screen. Yeah, we'll look at that in a minute. This just gives you a quick reference to tell you
Yeah.
what the room's doing.
Initially, all that data was only on
On the
air
main,
reg,
but
and then we
Now
started adding.
adding it
that
to the
on.
thing.
You said you click on that question mark and it brings you out there, or you click on the T-stat and brings you to there.
The question mark will give you,
You gotta
your
go to the folder. If there's something going to the folder, that's always
Okay.
that goes back to job data.
Okay.
All right. This is just strictly saying that
There is.
heads up. Anything that has question marks is patient care area stuff that we would have air regulation stuff too, air regs.
Mhm.
And if you wanted to see any quick reference stuff, you go here. Okay, showing that. If not, you would go to say, geez, I know my air regulation stuff. I go here.
Keep going up.
Mhm.
Back
Up
to Benny.
Top.
Yeah, main site map.
Main screen.
here.
Up,
Okay.
main
Yep.
screen, yeah.
Oh,
There you go.
and you go to air regulation for regs. And there's a lot of stuff. Then you would find
Benny, up top left.
Benny.
Yep.
I've never navigated this yet.
Mhm.
It's not much to get in there. Oh, yeah.
That will tell you back to the third floor that those patient care rooms that you clicked on, you know what I mean, would have something going on in there.
Mhm.
So those are the rooms. Those are the space temperatures, alarms, same things that we have to monitor, how many air these are adjustable based on all the regulation stuff that we have to do. Same as the other air rig stuff that we do. So all these rooms for different things will be Colin through historian is coming up with he's working on the air regs now for different areas. This is part of that stuff, so any reporting out of these rooms will be done through that trend server because they're all being trended. All this information is being trended in historian. So and then we'll come up with a canned report. So other words, you come to here and you need to have a report on room 3202. You'd go into the historian reports, go to the canned report, air regulation, whatever, room, room air regulation stuff. You pull down the drop-down menu of 3202, and then it's going to automatically print you the report with your date ranges and all that stuff. Make sense? It doesn't make sense to a lot of people because you don't know that part of it, but Jimmy did. You know what's going on with that now and all that stuff. And we'll share that as time goes on, how to get that information. Okay? I don't really have time. I don't want to spend a lot of time on that because it's different, whole different thing. All right? I want to spend time on the screens. Okay. Water, like we talked about. Click on that. Goes to the water, like we talked about. Airflow measuring. We talked about that on this floor. So we got exhaust fan 15, flow 299, supply, return, totals. That actually looks pretty good, that one. That's how I was hoping each screen would. And then UPSing, right? UPS you're looking at. Got it?
Mhm.
All right. Alrighty. Anything else on this floor, guys? Anything unique to this floor? Okay. Going up. Full floor. Mechanical space. All the layout on the mechanical space flooring that we had before, all that kind of good stuff. The things that we talked about already. Do you have? I don't know if we we don't need to bring that stuff up that we talked about already. You're working on that stuff as far as, I have to pick a different symbol, or do we already pick a different symbol?
We got something for Cabelco,
Okay.
but I'm not, the guy doesn't have his information.
So there's nothing to read just yet.
There's some stuff, yes, but it's not all lined up. He's coming next week to finish up his information.
All right.
So I mean, you can click on it. It'll be what the screen looks like, but the information is.
Right. So anything we hover over, exhaust fans, all this kind of stuff, we'll click on them real quick. We'll pick this for instance, it'll bring you to the matrix of the exhaust fan for the 4th floor now, and it'll highlight the one that you're looking at.
I did them
Not
all
yet.
yesterday.
Didn't take?
It took on mine, but I'm thinking maybe you have an older app.
Oh.
So
So let's say that, I don't know which one I just clicked on, but if I clicked on one of these, it should show you the one you clicked on and all the information about it, okay?
Some fans have more information than others, you know, depending on the system, but this is a summary of the exhaust fans.
Okay. One of the good things you can, if you always have questions about it, you know, what it's doing, how it's doing it, it's always going back to those floor measuring stations and looking at the exhaust fan that was associated with it. You know, exhaust fan 15 was the 3rd floor that we just looked at. We knew it had flow at the 15th floor. You know what I mean? So I know that damper's gotta be open, because it was on the 4th floor. And we know whether or not it failed. If there's something wrong with it, you also can go to the floor and just say 0 flow, go to those floor, or a little bit of bypass. That's the whole premise behind it. And it's toilets. It's floor 1 through 3 for toilet exhaust. Okay? Oh, I'm sorry, looked that wrong. Nourishment centers. 1 through 3 nourishment centers. Okay? That makes sense to you guys? What I just stepped through? That, real quick.
Is the RO, do we have anything for the RO water? Oh.
Mhm.
Hold on a minute.
I noticed it was, just.
Exhaust fan 15 had 301 CFM, right?
Mhm.
Exhaust fan 15's right here. Is that 15?
13,
Where's 15? 14.
15,
More
something like that, yeah. it's
Right one?
15 right there.
Okay, 15. That would highlight that since we clicked on it. We knew that the 3rd floor, if you had an issue with the 3rd floor exhaust, you know that's part of the nourishment centers. That's where it was coming out of, on that floor. Other floors have it too, but I'm just giving you an example. Tracing the stuff down. Okay? Alrighty.
Those exhaust fans, if you notice at 12 and 13 have a more of a in-depth screen that you can go to.
Yeah, I was gonna ask whether there's a different kind of hot
If you
button.
go back to
Yeah.
the
isolation.
They were white.
These?
Just
Go back to
click
the
on
next
any one of
screen.
those.
Yeah, you got a different kind of hot button.
See, yeah.
Yeah,
So,
you get 12 and 13. So.
That's
12
the isolations.
12 and
Right.
13 are for the isolation room, so they're gonna lead lag each other. So on these graphics, the exhaust fan 1 and 2 and 12 and 13 are gonna be unique, because you're gonna see a reset light that is on the bottom. In the center, you'll see a little
Yeah,
alarm that says reset light. So, just to explain that real quick, what ends up happening on those fans is that, with the isolation, if they're serving for the isolation rooms and they lead lag, they have a common damper. So, they have individual dampers, but they have a common exhaust and they have a common feed.
Mhm.
So if one of them fails and the other one starts, you're gonna end up rat racing a lot of your air. So we spoke about this in the past, that the sequence called for the damper to close on the one that failed.
Mhm.
Well, the thing that starts the fan is that the damper is open. So in order to shut the dampers if it fails, I have to lock the alarm in place to close the damper, because I have to shut the fan off.
Mhm.
So what ends up happening is that a light on the front of the panel will illuminate, and it's requiring a reset. So the lead fan that runs and fails, say it trips on a static pressure or something, it's going to actually command the fan off, because the static is tripped. It's gonna light this light.
Mhm.
So that is gonna give you an alarm that says that a manual reset needs to take place. The person's gonna go up to the fan, they're gonna find what it's tripped off on, low static, hit the reset button, and then they're gonna hit the reset button on the static, and they're gonna push the reset button, and it's on the front of the panel, and it will reset the process.
Okay. So what you're saying is in a failure rate, it locks into a failure mode.
It locks.
That
into
makes you
failure
take an
mode.
action to go up,
Yep.
reset to put it back in its normal operating mode.
Yep.
Okay.
I mean, I can show the guys, you know, I mean, you have to hold the button in, it's for less than 10 seconds. You hold the button in to allow the system to acknowledge that you hit the reset button and the light will go out. The light stays on and it still sees a failure. So, you know, if fan 12 was running as a lead and it tripped off on low static, it's gonna shut the fan off, close the dampers, it's gonna latch that alarm in place, and then it's gonna start the lag. So you go up there and you're like, oh, I have an alarm, this one failed, you're gonna say, oh, it's tripped off on low static. You're gonna push the low static, it's gonna reset, then you walk over to the front of the screen, the front of the panel, you're gonna have a red light to say that it needs to be reset, and the reset button's beside it. Push the button in, hold it for 10 seconds, the light's gonna go out, you release it, and the
That'll
system's
go
back
back
to
to the
normal.
lead feed.
Right.
But the lag fan, all of these exhaust fans, anything that lead lags, the pumps, the fans, they're gonna stay on for like 2-3 minutes so
Okay.
to prove that the other one is on.
Yep.
So you're not gonna have, like on an isolation or on a pump, you're not gonna, like on that 5 and 6 heat exchanger, you're not gonna have the lead pump on a changeover shut off and have no pump until that other drive comes on. You gotta be running in both of them, and then the lag will drop off.
Everybody good with this?
Mm-hmm.
And up here we have the heat exchanger thing. That's the one that we already reviewed. Then we have, like I said, all the exhaust fans that are around the perimeter area, and we have the Cabalcos up here. Those compressors, the 3 compressors up there. There is an informational screen, but it's just not filled in yet. He's working. This is what you'd see, but Jamie's trying to finalize with the vendor more information about the Cabalcos. Flashy lighties.
That's his
Christmas
issue.
light.
Okay.
And then the
Wow,
alarms.
I didn't like all the lights on the front,
Yeah.
that's pretty cool, that'd be cool. Where'd you get pictures from, them, or just get from them, you put them on there?
Yeah, that was from online.
Nice.
So, alrighty. We have pumps. This is the heat exchanger.
That's heat exchanger 4 for the glycol loop.
Snow melts, yeah.
Right. Can we? Does it say glycol anymore?
I'm
Alright.
adding all the descriptions to
Thank
each
you.
of the units.
So we got that. So
HEF
look at this one here.
unit.
Oh, nice.
That's the ones that, those are the little tiny ones, right, Ron?
So is this the glycol system that's going to be part of the informational screen that for the rest of the glycol stuff overhangs, or is this a separate just for the snow melt?
That's for the snow melt, and that's the so that is gonna feed your.
All
overhangs,
glycol.
All
This is-
glycols off H.
All glycol is off
Okay.
heat exchanger.
Alright. So all glycol's coming off this.
Well, there's 2 separate systems in a sense. The heat exchanger is gonna enable when the outside, as you see on the right, when the outside air temperature goes below 50, the heat exchanger is gonna enable, and that's gonna allow you to have heat available for your overhang fin 2 radiation. As far as the snow melt system goes, on the left, Jamie says snow melt, so there's a few things that need to happen before the snow melt comes in play. The outside air has to go below 38 degrees, and the humidity has to be above 80, which is signifying that it's potentially raining, snowing out, which is gonna start that system.
Adjustable.
And then once that starts, pretty much the thing just cranks heat.
Can I ask you this? If this is here, all right, set point, heat exchange enabled at set point 50.
Mhm.
So it's telling me right now it's not enabled. It's
Right.
not going to work because it's 67 out.
Right.
Does that mean everything's like I see here? Nothing runs. Pumps, there's
Yes.
nothing running.
Nothing running.
So this is adjustable.
Mhm.
So if we get stuff and we want to do whatever, we can maintain. Say if you look at those thermostats that were outside, it was set at 67 degrees. Remember we looked at that? We saw them at 67. You see that it's getting real cold out there, and you're like, wow, for some reason it's really cold under that overhang. You can come here if you wanted to, readjust the set point, fire this thing up, and get the temperature down if you wanted. You know what I mean? That makes sense? So if you had to in a pinch, you could adjust that down, but don't leave it there, and you can ask questions the next day. But at night, if you see something wrong and you don't see it, but that should be based on this, and based on the outside, overhang, you don't know what it's gonna do. You don't know if it's gonna hold temperature for some reason. It's gonna be really cold in there, and you got to do something about it. You know what I mean?
You can also adjust the temperature that's going down the pipe, which is your, just about to the top right of the HEX1, right there is your set point, the black, 180. You know, if you needed to, you can adjust that temperature as well.
The glycol coming out temperature.
Yeah,
Is
it's
that on a
fixed
reset
value.
schedule?
It's not on a reset, it's a fixed value, I believe. I can-
So, which makes sense because it's below
Yeah,
50. You
makes
want
sense,
heat.
yeah,
That's your
of
heat.
course.
There's your
Yeah.
discharge test. You don't want to reset it and never get the heat out there.
Right.
It's all about heat. Okay.
Yeah, you're just basically trying to protect that space. That is,
All the glycol areas.
And that, it's gonna maintain 180, and the differential pressure, set point of 10, which is on the far right, that DP valve is on the second floor, which, it's gonna maintain differential pressure for that.
Oh, really? That's on the second floor.
Mhm.
Can you write that down? There, Jimmy? Differential pressure valve. Just put a note. Second floor, where that's located. That's that valve, right?
Yes.
The sensory in the valve. That's located on the second floor. Okay. And this differential's got to be up at the heat exchanger.
That's,
The pumps are up there?
Pumps, for like the flow
Just
set,
a
for the,
switch.
for the flow switch, to say
Status.
approve of flow.
Right. And
So
then
that
we have the
approve of flow,
exchangers.
that you see no flow, that's that switch for them.
And this has got to be
That's on
low
the
pressure
fourth
steam.
floor.
Low pressure steam coming in.
Yeah.
So that's your low pressure steam coming in. That goes to heat exchanger. Trap comes out, comes across. We maintain this. We have a temperature set point of 180. We're trying to maintain. We have some high and low alarming. It's off, locked out because outside air temperature. And pumps aren't running because it's locked out. We've got proof the pumps are running. We have a differential pressure set point and valve down at the second floor, and we have this feeding out to those different areas, and it goes to the snow melts also. And we have to control the snow melts when this thing actually sends stuff to the snow melts is based on this.
Mhm.
And we have, we can override them if we want. And space temp.
So below each heater out there, there's a temperature, there's a temperature sensor, so you can see what the temperature is outside each one of those heaters.
Okay.
Do you guys know offhand,
It's pretty good.
Robert, maybe,
It's good.
anybody know offhand, those have automatic glycol makeup, or do you have, is it manual?
It's
Oh,
got a
interesting.
tank there in the room.
I thought I saw a tank, like
It's a
a
tank.
It's
storage
automatic or
tank.
manual?
Right near the cabal.
I don't know.
Okay, no, I thought this, no big deal.
It-
Yeah.
it's out behind
Just
the
curious.
restaurant.
Alright.
Yeah, I don't know Jimmy on that
Do you know
one.
if we have
It's a good one.
do we know if we have a low flow on that, Frank? If there's something set up, so we'll know if we run out of glycol in that tank?
It's not,
Keep our eyes on it.
Well, it's technically it should be a closed loop, and if you have problems and things getting low, there's probably there's probably a leak somewhere. We got issues.
Yeah.
But you're absolutely right. If we do have an issue, how do we make it up? You know,
We know that from the capital.
all these systems, all these closed systems, all these closed loop systems are managed in oversight, just like the rest of them, with Arian Waters. Arian Waters would be responsible for maintaining those, making sure they're always full, and to make sure they have the right glycol mixed for the temperature ranges they're supposed to have in them. And if they deem necessary, if they have to come up with a makeup feed system, they're gonna have to come up with it. Just like we did. We did the same thing over carp. They manage those. They make sure the glycol feed makeup goes on. Okay. I'm gonna move on. Back to 4 again on that one. FEP panels.
Each one of those has a UPS system, that's what you're pointing at right there.
So this is a little different now, right? This is this
UPS just like the others.
just like the other floors, but because this one doesn't have any areas really air handler serving thing, but it actually doesn't it have an H&B serving this area?
no, the
There's a
Canada
couple-
program has an HMV.
Couple
Right.
of boxes on the floor, that's about it, but,
There's 2 fan coils.
Yeah, it's fan coils.
There's 2 fan
VAVs.
coils that are,
There's a couple of
There's
fan
one-
coils up there.
they're
There's
right
one
by.
over near the Cabalco, right there, right above them.
Yeah, I'm
There's
sure it
two
says,
fan-
the
there's two fan
blue,
coils
the blue,
See
These?
the one,
That's
yeah,
the
see the
blue
blue
teak,
one near 75?
yeah,
Right
that's,
there.
that's one of them. The blue
That's
teak
one of them,
got
the other
fan
one's in the
coils.
back corner.
There's 2 fan coils.
72, see the one which says 72?
Three VAVs and
They're
2
two
fan
floor.
coil units.
Because it's right by the entrance to the old building, to the main building.
Yep.
When you walk through, they're right over your head here.
Yeah, the blue ones are fan coils.
Those are just where the T-stats are.
Well, okay. One thing this we might have to put in another hyperlink for like mechanical room ventilation graphic to show me how this all being ventilated, because I can't tell from here. I don't think we have any that actually tell us how this is being ventilated. We have fan cools, we've got an H&V that serves this thing.
You don't have an H&B that serves.
We don't have any H&V?
No, you just got
Do we have an
the
exhaust fan?
close.
No, we have,
You have an exhaust fan.
right
on
here.
The
the
fan calls,
exhaust
once they get over those
That's
unit
the-
heaters, you get unit heaters.
that's what you got for that, that should tell you what does the.
Well, hold on.
For the VAV that serves the elevator lobby, you have two VAVs that serve those electrical rooms that you see in the middle where the stairs.
Right here, I see that, yeah.
The two fan powered, the two fan coil units that you have, you highlighted there and there. One is above the Cabelco compressors, that's the
Yeah.
thermostat there, and then the other one is over by the steam station.
Over here?
And those run on temperature. If the temperature in the space goes above a certain
Mhm.
setting, whatever your set point is on the thermostat,
Okay.
it comes on, and then when it goes below it by a differential, it's gonna shut them off. So normally they're off, they don't run all the time, they're gonna cycle on temperature.
And if I click on that, it'll show that?
You click on that, you have your space at 75, max set point's 90. Min set point, you have your fan off set point, so when it goes above, if the temperature goes above 75 degrees, it's gonna turn the fan on, which the fan is on. And
Mhm.
if it goes to 73 degrees, the fan's gonna cycle off.
So we have control of the set points.
Yes.
Okay, I got it. Okay. And
What's that 80 down the bottom left, T-stat?
That's another one of the overhangs.
That's the,
That's another, that's the other one.
glycol?
For the glycol.
Okay, okay. Make sure you put the note there, glycol over there too, Jamie. And
Your steam station's there.
right, my steam station's there.
Condensate pumps.
Condensate pumps, PIV stations. Low pre, these are
All
the
the
set points.
FMPs all have, UPSs in them, correct?
Same thing as,
Yes.
Are you gonna put the
mm-hmm.
pre-vac pumps on the screen too? Because they're all in the corner. and
yeah,
look like,
highlighting the one that you just clicked on.
Yeah, a few of them, all the ones in blue don't have them behind them quite yet. That was one of the things I was working on this morning, which is why the black one is back.
The blues don't have something?
They don't have it behind. They don't have it behind them right now, so it's one of the things I was working on.
Okay, but these will go to,
Right, if you
they'll
look
show
at-
you the one that you just
Exactly.
clicked on, and the same thing. So, just so I understand this, I wanna make sure we have network switch closets with FEP, with UPSs in them. Those are the ones on those floors that we showed you. Then you have FEP panels, field equipment panels that are out there in the field. Those also have UPSs on them. So anytime you click on these particular field equipment panels, are all these on the graphics too?
Yeah.
Okay. So anytime we click on those, you'll know FEP panels and all the UPSs on those, and then all our networks and switches. That's huge. I mean, it looks like everything in that, every bit of this control.
Yeah, it's nice.
You know what I mean?
Some
be
of
able to
the-
keep
some
an
of
eye
the
on.
network control panels are shared with the FEPs,
Yeah, naturally. If you have an FEP and you have a network switch next to each other, they're off the same UPS.
Mhm.
and they
system,
still
yeah.
show on both screens.
They show on both. So. Okay.
Yeah. Each of the floors, for the most part, the occupied floors, not the mechanical floors, they have low voltage rooms. You probably noticed them by now. And we're not the only
stacked.
occupant. You've also got, I think, biomedical's in some of those. You have securities in there, fire alarm.
Fire alarm.
Yeah, there's other low voltage type systems that are in those rooms as well, yeah.
Well, this is, if you notice on here, see the panel locations? It's all the roof, it's all mechanical spaces. The roof, the lower penthouse, or full floor mechanical. Okay? Those are all your field equipment panels that are serving equipment. They're all on UPSs. You okay?
Yeah, just gonna step off for a second.
Okay.
Somebody's looking in. I was-
Okay. Does that make sense? So,
Sure.
all right. And those are all the FEP locations, FEP, FEPs, FEP here, field equipment panels, FEP, you know what I mean? That's wonderful. Really, really good job, you guys. This is really a long time coming. We finally conquered this standard too, so this is great. All right, air handling units, we know about those. Exhaust fans we talked about and all that kind of good stuff, so. Unit heaters,
Those are the snow melt units.
I think, I was gonna ask you.
Snow melts, I guess, I was wondering what they were.
are these the same as the snow melts? Because you got a snow melt thing on the glycol, and then you have
Yes,
Benny building
They're the
unit
same
heaters.
device, yeah, they're just shown on the floor plan as well, yeah.
I think we just need to make sure we marry up the same language here. Jamie, we just came across,
A unit heater?
yes,
Yeah.
the same as the snow melt. See how you can marry those up so they're the same language, same talk? Because this,
Yeah, it's like snow melt.
yeah, something. And what is these?
Those
these,
are in the sub-basement.
Oh, SP sub-basement.
Are they snow melters?
Those are in the fuel oil.
Unity.
Yeah, those are
Unity
unity.
heaters in the fuel oil tank. Corners.
Well, we need this screen going, but it's a summary screen, I guess. We've
Yeah.
kinda kept them all going on the site, but I'm not sure.
Yeah, I don't know if it's gonna be beneficial for this one here. We might end up just putting all that uniheater in that pop-up graphic for the fuel room and just leave it there. Because it's really a standalone,
Sure.
isn't it?
Yeah.
It's by itself,
It
and these, I think they're electric, aren't they?
No, they're
They're building hot water ones?
I think they're hot water, yeah.
Does anybody agree with that?
Hot water.
That it's, do we need it to have it on a thing like that? Or should we just keep it down the fuel room? If you wanna know anything about the heater, you just click on that graphic and get the information?
Yeah.
And then for these,
I'll just pop up the heat exchanger floor graphic,
yeah,
since
because
that's where they're at.
if these are, it seems like when I go to here,
Mm-hmm.
I got this.
That's where they're at. Yeah, I wasn't sure that they were showing, and in the rush to try and get all the information on the graphic.
Somehow we
I
have to
doubled up on it.
signify,
That says it's on heat exchanger one.
Yeah.
do we want this information
To pop up when you hit the unit
to
here.
pop up when we hit something Unity, but they put it something like a snow melt signal there, snow melt, so they understand that you click that, you get that snow melt. You know what I mean? Somehow you get the same kind of connectivity between the two.
Oh, I can just pop up heat exchanger floor data because the glycol serves it and
Yeah,
it's
because you want,
Yeah.
be able to see the source as well.
Right.
Yeah.
And is this the same information
Stages
as
have
the other one?
graph.
right.
Yeah, then I'd do that,
Yeah,
because this is
yeah.
just more confusing.
Yeah.
Does that make sense? And I'd put something instead of Unity, some kind of snow melt, snow melt, because there's only
The
two.
table system for that too, because in the, that,
Because to me, Unity,
Heat?
I'm thinking, oh, these things
They
are,
a unit heater.
yeah, but they're in, there's,
Yeah, I
instead
think
of
it's
snow
some
melt
mechanical space.
inside the air intake
Heat
intakes,
intake,
right?
yeah,
That's what they
yeah.
are.
Yeah, there's,
I know that, but that should say, because anybody that sees snow melt and sees them there, they're automatically say, oh, those are the intake snow melts. You know what I mean? And I don't even, if you want, I don't want to make
Unless
too
you
much
put
work
it
for
up
you. If you kind of
underneath
carve
the
this out and just put
57
intake and put the things here and snow melts, so it clearly shows that those are snow melts inside the intake. You know what I mean? And get rid of the U, because we don't really need that there
Okay.
to help that. Just put them inside there and put the symbols in there, even if you want to put the U's inside the intakes, or just write snow melts, whatever you want to do. And you click on those, and it brings you to full floor heat exchanger, to that snow melted thing that you're gonna control anyways. That's perfect. Okay. Condensate, high pressure steam, low pressure steam. That's the steam station that runs along here. That's good. We know about that. And we know about those. Anybody else? Any comments on this?
there are water detectors on the floor. I don't see them.
Oh yeah. Okay.
I made that
Do you have
note.
those guys? Okay. Water detectors.
And you, when you click on the PRV, does it come up like the end of screen too for the
Right here.
steams? Yeah,
That's
It's
all
just-
the information for the
Yeah.
PRVs right there.
alright.
You got high pressure steam coming in, medium pressure steam to low pressure steam. That's pretty much
What's
it.
the one on four, PRV four?
That's just it's the same. It's the same.
You have a
Low
second,
pressure
okay,
steam.
right over
you
there,
have a second
okay.
low pressure steam.
Exactly.
I think that feeds the penthouse, doesn't it?
Right.
Uh,
That no. That, from my understanding is that the, yes, the low pressure steam goes down here, it rifles across. Then you have low pressure steam. It goes like that, and all the steam lines run here, and it heads right here, and it goes up to 12 right in this location. And then it branches down here. Low pressure steam comes down here. It feeds the air handler. It feeds the glycol steam. It feeds something over here. Feeds a few things over here, not too many.
Diagram, we talked about
Yeah,
having
I
those
had it.
lines on there at
Yeah.
some point, yeah.
Okay, it's all color coded up there, so it's very easy to look at to see how everything moves. Okay. Moving up. 6th floor. Extension of 6 West from main building. This is the 6 West main buildings here. They do the breakthroughs, and then we have stuff over here. We did clarify what's going on here, so we have to make those modifications and changes. Okay, this is completely. It's not an isolation room. It's called a protective environment room. It's positive, it's not negative. It's not considered, we have to take it out away from any kind of isolation wording, because it's really not isolation, it's
Okay.
protective, what's called protective environment room. It is no different than any of these other room that's up there, other than it has an ante room.
Okay,
It's fully functioning the same exact way as it's any one of these rooms.
okay,
I don't get it. Supposedly it was a change in the beginning of the project where DPH wouldn't allow them to put a negative room inside of a positive HTC suite. So they said, well, keep your ante room, keep everything, but make it all positive. So you can make a buffer room, you can make it positive, but you're gonna have to put a buffer ante room and all that stuff, which it all flows the same way. It doesn't make a hill of beans sense to me at all. But from a graphical and a whole flow standpoint, we've gotta make it the way it's, that they're saying that it's gonna operate.
so make it pink,
Make it pink,
change the,
it's a,
okay,
it's a
HSCT.
but now
suite.
but you gotta call it out as a protective environment room, because that's kinda how it's labeled on the plans. These are positive pressured rooms, and this is considered a protective environment. You know what I mean? So full boat graphic, call it not isolation, but protective environment, because it's not a negative isolation room, you know? And we'll go from there, alright?
So I'm assuming in the future, we're gonna have all refrigerators and freezers on there too, right?
Well,
Oh, there are.
as you get
We'll
to
get
the
to them.
higher floors, yes.
We'll show you how it's gonna be.
What's the pink E?
All these pink,
The,
Pink E, the pink elephant right in the middle of the hallway.
You saw the exhaust one.
where are you?
Right there.
There you go.
Right there.
Oh, that?
That
What
exhaust.
the heck is that?
That's right.
I'll click on it.
It's a stray exhaust is really, it ended up getting assigned to a couple of
no, no,
babies.
no.
Yeah.
I remember this
We
one.
went over this one.
We went over this one. It is different, guys. If you had what they did is they didn't have a pair of boxes of something for they don't have a matched set of boxes like they do in, like, you know, in like an arch room. You got an exhaust box and a supply box for one thing. What they did is they had two supply boxes in the area and only one exhaust box in the corridor area. So that's the sister married up programming, if you will, to two supply boxes in an exhaust box. Okay? It's looking at those two supply boxes, and that one exhaust box, that E, one exhaust box,
Okay.
is
Alright, I see it.
tracking those two supplies.
Alright.
It's a unique setup, we had to
Yeah.
display it somehow for you, so you knew how it worked. And
That is the big elephant.
So-
Helps along, yeah.
You would have, like, say, this box,
Yeah,
and maybe this box, I'm assuming, I'm just taking a guess, and it's got one exhaust box in the middle or something,
it's probably
and
the
so
one
it's
down
tracking
there.
these two and doing something here. Is that right?
It's probably the one where it says 71 and that, and keeping the car.
71, 71 maybe, and
I
this one
wonder.
here, I don't know.
Looks like there's three different.
But you got one here?
Three different setups.
And you got one there. Okay. I think what I asked last time is I wanted a thin line running to the ones that they do, so that when you could see, oh, this box is this,
Show the
this box
association.
that, this box that. All right?
mm-hmm,
We just wanted just a line going to them, so you can know that E is associated with those two S's. Okay? Everything else should be pretty standard, the rest of them. You know?
there's,
Each one of those rooms. Go ahead. I'm sorry.
well,
Should I
if
hold
you-
off?
If you back out one, but
Go ahead.
the, right at the spot where the garden, I don't know what they're calling that area,
yeah.
but there's
There's a
a,
little ante,
mess.
room
So,
going out,
yeah.
vestibule.
so that
Yeah.
is also on that other drawing, if you click on that, it's down the very bottom.
Oh yeah.
Oh.
Uh,
It's
make-
it's a unique setup as well,
That's hot
so.
water. That's hot water though.
I would just make it by itself. You click on the T-stat and just make it its own little own screen for itself, so we know what's going on with that. It doesn't have to be in the big one. Okay. All right.
You have another little fin tube radiation behind the elevator there on this floor.
Yeah.
Yeah, those are what I was thinking. That was on the 7th floor, but
It's not on every floor for some reason, but.
It's 6, 8, and 10, I'm pretty sure.
Oh, there
I mean, those settings there, I don't know how warm you want it behind the elevator, you know, so I mean, that's 7 degrees, so.
you go. Set it right
Yeah.
on.
Probably
probably
68.
put it down there,
Yeah,
whatever.
put it
Those
down.
also have low alarms on them too.
Okay. It has low alarms,
I believe those, you'll get a low alarm,
low temperature alarms.
yeah, behind those.
Can we get that? We need to get the. if there's an alarm, I think we need to have that, right? All those alarm set points? If it's a low alarm, tell us that it's a low alarm.
You may not wanna fool them, they're more.
I don't wanna-
Isolated space, you may
Yeah.
just wanna leave them behind the scenes.
Yeah, I mean, that's something that's in the controller level if you want, you know, we put that in there for, just in case, cause, you know, obviously if something happened in the valve, but if you want adjustability to it.
Do you think we need adjustability
All
to it?
of them
No,
are set
I don't
for
think
40
so.
degrees, so if it gets below.
Oh, yeah, no, I don't need that then, I
Yeah,
don't need
they're all
it,
set.
it'll come to
Scratch
us,
that.
never mind, Jimmy, take that out. So, we'll add 50 and take off
Trying to
one.
save your behind.
That's why they're not there.
What's the red T stat?
Isolation one.
Yeah.
On the left, it says it's a fan
Oh,
power.
yeah.
Fan power, too.
It's a fan
See up,
power.
see up all that pink box on the left?
Oh, there they are,
There's
yep.
a key, there's a
Thank
key
you.
up there with all the
That's what-
symbols.
There's also an F key you can hit to get all those, right? Was it?
Yeah, but it's not really up to date.
There's so many of them.
I'm sure it will be though.
So we got area served by air handler, and if you notice this one here, we bump up to BB2. Because everything below 4 and down is BB1, and everything up the floor is BB2. So this is all shaded off in BB2. We go here and we get all our flow, exhaust, and this and that, and all that stuff. So supply to the floor, exhaust to the floor. That actually looks really good because this is supposed to be a positive pressurized suite. So that looks good. Don't know if this is exact, but it appears to look good. And then right, sure enough here, we go to the UPSs like we talked about. Going up there, the network switch closets. These switch from over here in the building and they kind of rifle over and 4th floor goes up. They kind of stack above themselves over this way. Click up, there's the UPS at 6, there's your stuff. I'm going to kind of, for time reasons, I want to just keep us flowing here. But please, stop at any time, stop me. And these always hyperlink to BB2 now. I know I didn't go through the A handlers, but we'll go through those afterwards.
That's the overrides.
Okay. The hyperlink over to the other side, we know about, and all that kind of stuff. One thing we don't have down here, which I think Robert is going to have for you, Jamie, is these the bioclimactic, whatever they are, the
Polishers.
air polishing units. We
Yeah,
have them
yeah,
all.
okay, yeah.
So,
Just
spot them on the graphics where they are. There's a lot of them spot all over the hallways here. We'll just come up with a symbol here and put the units on there.
Okay.
Alright. Alright. He'll give you, we have all that information today. He's got all that information, all the graphics marked up.
Fantastic.
You're the best. We'll keep you busy for the next 6 months. Alright, moving up. 7th floor.
Yay.
Okay? 7th floor. Some of the interesting things on the 7th floor is MRI suite. Alright. Here we go for another MRI. So it's pretty much a duplication. So anything we talked about on 2, Jamie, apply it to here.
Mm-hmm.
All the information. Alright. And
Look at that, your crack data.
crack data. Oh, we get the crack data. So this is the Liebert unit data. So we got it on this one.
That's a little up and to the left.
Right
There
there?
you go.
Oh,
Yeah.
this
Yeah.
is the box.
Yep.
This is the box data. This is the CAC data.
Mhm.
Liebert unit data. Okay. So everything we applied downstairs will apply here. Same thing. Purge, O2s, fan overrides, and all that stuff. Hey, let's see if I do this one. Should I override this one?
No.
Just
You wanna
check.
take this
Check
out?
on both. Right. Do them both when you do them. And this takes you the hyperlink to that same graphic we talked about. It's the same, heat exchange we talked about already. Okay, serving the same thing. Okay. Back to 4. That's the MRI thing. Moving through here, we got some stuff in here. Mega room. It's a
like
little
an
different.
MRI. You've probably seen it. It's the one with a different type enclosure. It doesn't have the metal walls
Yeah.
like the other one does.
Is it the whole area?
No, just that
This
square.
little rear?
Yeah.
So let's look at. So we just serving. We're just putting a box in. That's all. Nothing fancy.
It's got a humidifier on it. This is the one that I said out of the 3 humidifier, you have the 2 MRIs, 7
Yeah.
and 2 that have those isolation valves,
Yeah. Lockouts.
those lockouts. This one does not have that.
Different style humidifier, I guess.
Okay. So look at this one here. We got this serve meg room up here. These are going to be interesting things, guys, because these are the kind of things that we're not used to, that we have to make sure we get down pat. So max set points, okay. Duct reheats, reheat over, okay. Min flow 1,000, max flow 1,000. It's constant volume. Actual flows Why is that?
Whoa,
That there is, that Charlie must not have released that, because, when we did testing on that, so that, it's only like 100 CFM.
Instead of 1,000?
It's not, Charlie forgot to release that.
Alright, we'll take care of that one for us.
whoa.
And then actual flow, we'll fix that, then flow set points, we'll fix all, they're gonna fix all that. Differential set point 0, I'm assuming because the exhaust is gonna match that. It's constant volume neutral room.
You can change those to what they are, Steve, if you want, but that's
Okay.
supposed to be, I'm just checking.
100?
I believe they were 100, but there was a, we're just doing some of the flow switch to get more flow for it. But they are 200 and 100.
Min,
Max flows 200, min flows 100.
so it is a VAV, huh? It's gonna be interesting. And min flow is 100?
Yes.
Actual flow, we'll see, flow set point 100.
That's why
What
it's
about the
pretty
differential?
It's a, I believe it's a neutral room.
So,
I can tell you if it's a neutral room, yeah, he didn't change.
so as long
anything.
as I leave that at this, it'll track that.
Yes.
If you go to that, it's gonna track whatever the supply currently,
Okay.
not too much set point, it's gonna track,
The actual,
it's gonna track the actual,
Right here.
maintain the flow relationship.
It's gonna track that.
yes.
And that box should be, these should be matching.
Right, as you
The
see,
actual here
flow is gonna
should-
reflect the change of the exhaust flow set point.
So I'm assuming, I'll ask this question, these should match. That one and that one.
Well, at least
That
the
one is
actual
set
flow and
point.
the exhaust flow is set point. So the actual flow,
Well, that there, the actual flow,
Is now the exhaust flow set point below it, see, now it's 445,
It's gonna try and keep it.
whether or not the actual flow is gonna match it is,
right?
it should.
it should,
But
technically it
that
should.
But that
set
box
point
can't
should
do it
match
right
the
now.
actual flow.